did you initially get involved in this investigation? You know, what was kind of the reason why you chose these hydrogenases? Like,
well, this goes way back actually to when I was a student, and I'm thinking about when I finished my fourth year and I wanted to do a PhD. I got really interested in enzymes that contain metals. So I looked around the UK for labs that worked on metalloenzymes, and there's actually one in Dundee that worked on nickel-dependent hydrogenases, which actually I didn't know anything about at the time. And then I came to learn more about it, and actually I've always, from those days, which that was 1992, I've always studied hydrogenases since then.
Since 1992?
Yeah, so it's one of my favourite enzymes, probably because it's got lots of different applications. You can study it if you're into proteins, you can study it if you're into metals or into physics. As you've seen in this paper, there's lots of, complicated physical techniques. Or you can study it if you're into biofuels and bioenergy. So it's, it meets a lot of interest in the sort of things that I like to do.
So you know a thing or two about them? Well, the paper obviously focuses on hydrogenase.
Yes, I know it.
Obviously it focuses on hydrogenase 1 and 2. Could you briefly give us the difference between the two of them?
Yeah, so it's interesting so you'll often read in textbooks that bacteria just have one gene, they have one chromosome and they have one gene. And then the human cell has got 2 chromosomes and 2 genes for everything and stuff like that. But actually bacteria are more complicated than that, because they tend to have more than one gene for similar enzymes scattered across a single chromosome. And what E. coli has, it's got a gene for hydrogenase 1, which it expresses in late stationary phase, and which it co-expresses with a cytochrome oxidase. And I think it's there, and it's an oxygen tolerant enzyme, so it can operate in air. And I think it's there just in case the environment changes and E. coli moves from anaerobic to an aerobic environment, and then it can still use hydrogen under those conditions. Hydrogenase 2 is expressed in a completely different condition. It's not expressed in the stationary phase at all. It's expressed in the early stages of anaerobic growth, and it's used to generate a protein motor force, which gives it energy to make ATP. So they're expressed at different times. One of them can withstand oxygen attack, the other one can't. So they have slightly different properties. So E. coli is clever in that way, and it modulates the expression.